Hi, I'm Andy and this is question 6 on the AQA Core 4 paper from June 2014. For more questions on this exam paper, click the I in the top right corner. In question 6, we're told the equations of L1 and L2, and we're told that P lies on L1 where lambda is -1 and Q lies on L2 where mu is 2. And in part A, we're asked to show that the vector PQ is parallel with 1, -1, 1. So the first thing we're going to do is figure out where P and Q are. So to find the vector OP, we're going to use this equation here with lambda as -1. So we have 4 minus 1 lot of -1, that's 5. -5 minus 3 is -8. And 3 minus 1 is 2. We'll find OQ in a similar way. We're told that Q lies on L2 where mu is 2. 7 plus 4 gives us 11. -8 plus 2 lots of -3, that's going to give us -14. And 6 plus 2 is going to give us 8. Now that we know the values of OP and OQ, we can find PQ. To do that, starting from P, we go backwards to the origin, so that's minus OP. And then we go forwards to Q, so plus OQ. A better way of writing this is OQ subtract OP. So that gives us 11 minus 14, 8. Minus 5 minus 8, 2. 11 minus 5 is 6, minus 14 plus 8 is -6, and 8 minus 2 is 6. So remember, we need to show that it's parallel to 1 minus 1, 1. So we can say that PQ is equal to 6 lots of 1 minus 1, 1, and that means that they are parallel. Remember, whenever you could multiply one vector by a scalar and get another vector, those two vectors are parallel. In part B, we're told the lines L1 and L2 intersect at the point R, which has coordinates 3, B, C. And in part 1, we need to show that B is -2 and find the value of C. So, if L1 and L2 intersect, that implies that we can form 3 equations from here which must be true for some value of lambda and mu. And we get these 3 equations by considering the x and y and z components of each of the 2 lines. So we can say that 4 minus lambda from L1 must be equal to 7 plus 2 mu from line 2. Then we look at the y parts, -5 plus 3 lambda must be equal to -8 minus 3 mu. And finally, 3 plus lambda must be equal to 6 plus mu. So from here, I'm just going to put these into my calculator using the equation mode. So A and B are the values of lambda and mu, and C is the constant. And that gives us lambda is 1 and mu is -2. If we were asked to show that these 2 lines intersect, we would then have to check these 2 values satisfy the third equation here, but unless you want to check your answer for the other parts, there's no real reason to do that. So we still need to find the point of intersection, and we could do that by either substituting lambda into L1 or mu into L2. I'm going to use lambda equals 1, and that's going to give me OR equals 4 minus 5, 3, plus 1 lot of -1, 3, 1. 4 minus 1 is 3, -5 plus 3 is -2, and 3 plus 1 is 4. So the coordinates of R are 3, -2, 4. In part 2, we're told the point S lies on the line through P that is parallel to L1. And the line RS is perpendicular to the line PQ. All that's shown in the diagram. We have to find the coordinates of S. Now, in my opinion, with these kind of questions, it's really important that you draw a clear diagram and you label on it the things you know. For example, we know that r is 3 minus 2, 4. It's useful to know which points you know and which you don't. We know the value of p, that's up here, that's 5 minus 8, 2. And we know the value of q, that's 11 minus 14, 8. So we're trying to find the coordinates of S, or the vector OS. To do this, I need to break the problem down into several steps. First, I'm going to find an expression for vector SP using the fact that it's parallel to RQ. Then I'm going to use SP to find an expression for the vector SR. Then with the expression for SR, because it's perpendicular to PQ, I'm going to do the dot product of SR, PQ, that will equal 0, and that will allow me to solve for the parameter on this line SP. Once I've got the parameter, it's fairly straightforward to find the coordinate of S. So, first step then is to find an expression for the vector SP using the fact it's parallel to RQ. Now for this part of the problem, when I'm finding vectors, I'm not going to be writing down the calculations to do them because it would just get very long-winded. I'm just going to do them using the diagram. So the x coordinate from R to Q will be 11 minus 3, which is 8. For y, we'll get minus 14 minus 2, that's minus 12. And for the z coordinate, we've got 8 minus 4, which is 4. So because SP and RQ are parallel, I can say that SP is some multiple of this vector here. I'm going to use the letter T to represent that. Now I could, if I wanted, simplify this vector down, and that might make the arithmetic a bit easier, but it might overcomplicate what we're actually doing, so I'm just going to leave it as it is. Now that I know SP, I want a vector to represent SR. To do that, I'm going to go from S to P, which is this here, and then P to R. So before I do that, I'm going to work out what PR is. Subtracting the x coordinates, I get 3 minus 5, that's minus 2. I get minus 2 minus 8, that gives me 6. And I get 4 minus 2, which is 2. Now I can work out what SR is equal to. I'm going to get SP, forwards along this one, plus PR, forwards along this one. Combining these two parts together, I get 8t minus 2, minus 12t plus 6, and 4t plus 2. Now that I have SR, I want to do the dot product of SR with PQ. That means I also need to know PQ. But I do know PQ already because I worked it out earlier. PQ is 6 minus 6, 6. So now I'm going to do the dot product of SR with PQ, and because they're perpendicular, I know that will be 0. Now if I wanted to at this point, I could pull out factors of these to make the arithmetic easier. I could pull a factor of 2 out of here and a factor of 6 out of here. It won't make any difference to the answer, so I'm not actually going to bother to do that. So using the dot product, I'm going to times the x part here by the x part here. That's going to give me 6 lots of 8t minus 2. The y parts give me minus 6 times minus 12t plus 6. And the z parts give me 6 lots of 4t plus 2. And that must all equal 0. So I get 48t minus 12 plus 72t minus 36 plus 24t plus 12, and that all equals 0. That gives me 144t, and I've got minus 12 plus 12 is 0, and then I've got minus 36, so minus 36 equals 0. So if I move the 36 onto this side and divide by 144, I end up with t equals a quarter. Now that I know what t is, I can write down an expression that represents SP, which is t multiplied by 8 minus 12, 4, which gives me 2 minus 3, 1. Finally, I need to think about how I can get from the origin to S, which will give me the coordinate. To do that, I could go from the origin to P, which I know, and then from P to S, which means I want negative SP. 5 minus 2 is 3, minus 8 plus 3 is minus 5, 2 minus 1 is 1. So the coordinate of S is 3 minus 5, 1.